So in this video, we're going to talk about Lewis structures. Now what are Lewis structures? Well, they are used to represent the covalent bonding of a molecule or ion. How to build a Lewis structure? As you can see, this is the incorrect structure, and this one is the correct structure. The reason why this is incorrect is because you need to fill in all the surrounding space of oxygen. You cannot just jump straight onto filling a double bond. It doesn't work that way. For an effective way to get the Lewis structure correct is to write the diagrams for all atoms involved in bonding and add up to the total number of valence electrons that are available for bonding. Now let me introduce Lewis structures for you. The Lewis structure shows the bonding relationship between atoms of a molecule and the lone pairs of electrons in a molecule. An electron in the Lewis structure is represented as a dot, which is an electron, as you can see it right here. A bond is made up of two shared electrons, which represents 2 or 3 pairs of electrons. Lone pairs on the outer rims of an atom are represented as 2 dots. As you can see, these are lone pairs. Now let me reference back to what I said earlier. As you can see, if I just get rid of this one, this would be a lone pair. An electron in the Lewis structure are outer shell electrons, which are valence electrons. Here we have an example, CO2. Now let me walk you through how to do a Lewis structure problem. Now you need a periodic table. So you reference C in the periodic table. And as you can see, C is in column 14. So it has 14 valence electrons. But you did not put 14, you put 4. Now you go back to oxygen. As you can see, oxygen is in the 16th column, but you did not put 16. You always put 6. So you multiply it by 2 because oxygen has 2. Now if you add all of that up together, you would get 16. Now as you can see, there are 4 lone pairs, but you wouldn't call them lone pairs. You would call them double bonds because it's a double. Now if there were 3 of them, you would call them triple, but if it was alone, it's a single bond. Now let's look at another example. NH3, which is ammonia. Now let's reference back to the periodic table, and let's find N, which is in the 5th column. So it will be 5 plus, let's look for hydrogen, which is in the 1st column. So it would be 5 plus 1 times 3, which is 8. Now the structure of the ammonia only has 3 pairs of single bonds and 2 on the outer rim of nitrogen. So as you can see, this is the final structure for ammonia.
Write the skeleton. So with the first element, you put that in the middle and you get the second element and surround it, and you either connect it with a single, double, or triple bond. The second step is to fill all the octet with the outer atoms, so each one has a specific amount of circles.
Valence electrons. There are the outermost electrons used to form a bond to another atom. So, you want to know how many valence electrons are in an atom? Well, here are some steps. First, you find an atom on the periodic table. Here's the periodic table. Second, you find a column with a number with the A on it. So, let's say, for example, here. If you look closely, you can see that there isn't one A. Okay? Third step. The number that is above the A is the number of valence electrons. So, for example, if we look at column 14, technically, the A is right there, and if you look at the number, it's 5. 4. An exception to this is that helium has 2 valence electrons. So, if you look at the periodic table, helium is right here. It doesn't count as down the column as number 8, since it's considered a nonmetal. So in the nonmetals, it's considered 1 or 2. Okay? So yeah. Okay, with the steps that we learned, we can do an example. So for the first, I chose carbon, nitrogen, hydrogen, oxygen, and chlorine. These are the ones we're going to be using to find the number of valence electrons in the atom, the Lewis dot structure, and how many bonds the atoms carry. So let's start off first with carbon. So if we look on the periodic table, you can see that carbon is right here. So in this column, you would look at the number right here, the Roman numeral, and if you see it's a 4. So you'd go back to your chart, you would write 4. Okay, then we would go back and we would go to periodic table, and you look again, and we are looking for nitrogen. So you would go look here, and if you see, there is a V. So the Roman numeral for V is 5. So we go into nitrogen and we write 5. Okay, and you repeat this step until you finish. So hydrogen is 1. So 1. Oxygen is 6. So you would write 6. And last is chlorine. So you would look, and it is under 7. Okay, so now that you have your valence electrons, you go on to the next thing to find Lewis dot structure. So with the atom that you have, you put in the middle, so carbon, and the number of valence electrons surround the atom. So now that we have 4, we have to put the dots, which are 1, 2, 3, 4. These represent the number of valence electrons in the atom. Okay? So in nitrogen, there are 5. So what you can do is create 5. See, now that you have 1 in each place, in 12 o'clock, 3 o'clock, 6 o'clock, and 9 o'clock, you could repeat the steps until you have the number of electrons. So, yeah. For this step, or for these steps, when you do the valence electron number, you can put it in any which order you want, as long as it has the number of valence electrons needed in the electron. So in hydrogen, there is 1. So you could put it here, 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 or here, anywhere you want. Okay, so oxygen, there are 6. So 1, 2, 3, 4, 5, 6. Now, a rule that you cannot, something that you cannot do is you can't do 2, 2, 1, and 1. You have to go around the counterclockwise. That way it's easier to have the number that's needed. Okay, so chlorine. There's 7. So again, 1, 2, 3, 4, 5, 6, 7. Okay? Okay, so to know how many bonds there are in each atom, you're going to figure out what the octet rule is. The octet rule is that each atom wants to equal to 8 valence electrons. Exceptions: hydrogen and helium want only 2 valence electrons. So all the atoms on the periodic table want to equal to 8 valence electrons, except hydrogen and helium. Okay, so if, for example, carbon wants to equal to 8 valence electrons, they are going to have to add 4 more electrons to equal 8. Okay, so the example shows that 4 plus 4 equals 8. So you would need 4 more bonds to equal 8 valence electrons. Okay, so for nitrogen, we have 5. So if nitrogen wants to have 8 valence electrons, you would need to add 3 more valence electrons, 3 more bonds to equal 8 valence electrons. Okay? Now for hydrogen, this is where the octet rule comes into play. If hydrogen wants to, since hydrogen does not want 8 valence electrons but wants 2, you would only have to add 1 to equal 2. Okay, so for oxygen, you would have to go 6 plus 2, that way it equals to 8. So 2 bonds equals 8 valence electrons. And everyone knows 7 plus 1 equals 8. So you need 1 bond to create 8 valence electrons for chlorine. Okay. Draw a Lewis structure for H2S, hydrogen sulfide. So first you start off by looking. Okay, so here in the Lewis structure, you see that there's 2 lines. Those are considered single bonds, and you can each one signifies for a number. So 1 is 2, 1 line equals 2, 2 lines equals 4, and 3 lines equals 6. So if you were to add up hydrogen and hydrogen, you get 2. And then you add that to S, and you get H2S equals 8. So these right here are 2 lines, so each represents 2. So 2, 4, and here since hydrogens are 1, we don't really count that, and since sulfur is has more valence electrons, you can add the dots on there. So 1, 2, 3, 4. So in total there should be 4 bonds. Okay. Bye. How are Lewis structures useful? Lewis structures are useful in predicting molecular geometry in conjunction with hybrid orbitals.